Welcome to the Data Future channel. This is Shekhar and I am a data scientist. So, in this particular session, we are going to see uh, a machine learning project. We are going to develop a predictive model and we are predicting whether the email is a spam or not non-spam, okay, by using a naive Bayes algorithm. Okay, so we will start from the scratch and we will predict the emails, we'll check the accuracy, we will evaluate uh, the model um, in the in this session. Okay, so let's get started. So uh, this machine learning project is of email classification basically, and it is more related to a text analytics, okay, project. So here we are using a naive Bayes algorithm. Okay, so what exactly is the naive Bayes algorithm? So this is the classification technique. So and which is based on the naive Bayes theorem basically. So what is the main assumption of naive Bayes theorem is it is considered the all the predictors are independent. Okay, so it is considered there is a no any um, uh, every feature in this data set is independent uh, and that are not um, unrelated, we can say. Okay, so naive-Bayes classifier is popular superlearning algorithms used for the classification tasks such as text classification. So that is very important, text classification. It is belong to generative learning algorithm uh, where which means that it models the distribution of inputs from given class category. Okay, so basically, this approach is based on the assumption that the features of the input data are conditionally independent given the class, allowing the algorithm to make predictions quickly and accurately. Basically, in the statistic naive-Bayes algorithm classifier are considered as a simple probabilistic classifier that applies a Bayes theorem. Okay. This is all about this naive-Bayes algorithms. Without putting more efforts on this particular naive-Bayes algorithm, let's get started with the practical implementation of naive-Bayes algorithm in Python. Okay, so this is basically is the naive-Bayes theorem where the probability of A being true given that B is true. So this gives us it's a product of the probability of B being true given that A is true and the probability of A being true divided by probability of B being true, and based on this the probability we are the classifying the different classes. Okay, so this is all about the mathematical things behind this particular algorithm. So let's start with our Python notebook. Okay, so initially we have to import all the required libraries like pandas, numpy, matplotlib, Seaborn. So basically these libraries we required for the data manipulation and data transformation, so and the data visualization basically. Yes. So the second part is we have to load the data, means we have to read the data from the different types of the files like CSV, Excel or text file. So here we are using a CSV file and that is present in my folder itself. So there is no need to give the path, but if it is in the local machine on the local machine and it's in different folder, then you have to give the absolute part of that particular file. Okay, so here you can load the data. Now you can see there are two columns, one is the category and second is the message. So message is the nothing but the email message. Okay, so email and this is the category. Ham means it's a non-spam, means it's a true email actually. Okay, and spam means uh, uh, the email which is related to something like lotteries or some phishing emails. Okay, something like that. Okay, so there are two columns. Let's check how many rows are there. Yes, 5,572 rows records, and the two columns are there here itself. Okay, by using a dot save, already we know that. Here we have used pd.read.csv to read the file, and dot head means it will show the first five records. Okay. Next one, we will check the value count for this particular category, because we know that already there are two categories, and when you say, so non-spam messages are 44,825 and spam 747. Okay, so maximum percentage of these are the non-spam actually. Okay, so what you have to do is you have to df dot the column name, and then you have to put value count, so you can see this category wise the count. Okay, you can visualize it by using this, because already we are having this, and I'm using a dot plot function and providing the argument as a kind is equal to bar, means I want a bar chart. So you can see in terms of bar chart you will get the count. Ham is having maximum 1 and spam is having lesser number of as compared to non-spam. Okay, now here also you can do the some group by function on the basis of category, and you can describe that. Basically there is no any numerical columns are there, so there are two categories you can see here. This gives the count. These are the unique number of records in this category here, and these are the top this is the frequency, okay, of these emails. Okay, now next thing is we have to check the whether there is any duplicate records present in the data set. Oh, there are 415 records are there which are duplicate one, means having the same categories and the messages are there. So the next thing is you have to remove the duplicates or drop the duplicates by using a df dot drop duplicates. Simply you can run this, you will get all these duplicate record will be dropped and only one record will be kept inside the data. Okay, so you can check the data set. Now we have removed, and finally we are having a 5157 rows and two columns. Okay, next one is now this is our target variable actually. So target variable is the spam, this spam and non-spam categories. So we have to convert this into a numerical format. We will say if it is a non-spam, then we will say it's a 0. If it is spam, then we will put as a 1. So in the next step, what we are doing, so we are doing converting this spam into 1 and non-spam into 0, because our machine or the model will understand only the numbers. Okay, so here is the def span in quote. Here we are providing x. If x is equal to spam, then it will return 1, else it will return 0. So I will create a one more column is spam. Okay, is spam um, in this data frame itself, and I'll apply that function, this is the customized function to this column. So based on the category, because this category we have to change, and if you apply this by using a lambda function x of, we are use this customized function here, then whatever so what it does, so it will apply this function to each and every row of that particular column, right? So and it will create a new column. Okay, so after transformation, so let run this, and we can see, yes, now you can see here is spam is the new column, and ham is become 0, spam is become 1. Okay, so means this 0 means non-spam, and 1 means it's a spam email. Okay, now we have no need of this category now, so we can drop that. So how to drop the columns? So df dot drop, you have to provide the column, and if there is a list of columns, then you have to provide it in square bracket. Okay, and you have to mention the axis means column. So axis 1 means column. So this category is in axis 1. Okay, then only it will drop this category. Okay, when I run this, you can see now we are having the data without category. Okay, yes. Now we will check the 0 and 1. So already we can see 4516 and 61641. So now what we can see here, this data is very imbalanced. Imbalanced means there is a no, this is the majority class, that is a non-spam, and spam class is minority class. So whenever you provide the data like this to the machine learning algorithm, what happens, it will try to give the more weightage to the majority class, and this algorithm will misclassify some of the records. To avoid that, we have to balance the data. So how to balance the data? So what we'll do, so we will only pick up, we will make this date this the these classes equal with equal records, what we can say. Okay, so instead of using a 4516, we will use 641 out of this 4516, so that the spam and non-spam will be uh, equal. Okay, so for that what you have to do, so you can use the the data. This is non-spam. So non-spam, I have considered the data frame, and I am giving a condition equal to 0. 0 means non-spam. Dot sample. Okay, dot sample means or what I'll do, I'll show you what exactly it is. Okay, non-spam uh, here. Okay. Hmm. Okay. So what I'm separating this filtering the data. So now df2 is this. So df2 I'm filtering on the basis of this condition. So whatever data present here is the non-spam, right? Non-spam. So if you check dot head, you will see all the non-spam records. Okay, now what I'm choosing only a 641 rows from this particular data set. So I'll consider another data set, non-spam df. I'll create and put it here, and using a dot sample, and it will randomly select 641 records, and then you can check the shape of this new data frame. Yes, now here the 641, and here is the 2. Okay, means our data set is ready. From means we did the undersampling here. So 4516, we dropped the samples to 641 because we have to balance the data. Okay, now for the spam df, we have applied this condition, and we are having a spam data. Spam data is also 641. Now we are having a separate data. Now you have to combine this data. So we have to combine. Okay, so combine two data frames. Okay, two data frames means one is of spam, another is of non-spam. So what I'll do, so I will say it's a balanced data, and there is a concat function is there, pd.concat, and we have to join these two data frames, and this is the spam one, and axis is equal to 0. Axis is equal to 0 means one one after another it will add the records. Okay, if you say axis is equal to 1 means column wise it will add, but we don't want column wise, but we will add it the row wise. Okay, so we have added here the two data frames we have combined. Okay, so just like a stacking. Okay, now you can see here, and the final data balanced data set is 1282, means 641 of one class and 641 of another class. Okay, so here also you can check how this balance is. Value counts, I'll say. Okay, so you have to give the here is spam. We'll check. Yes, now this is matching, or also you can plot a kind equal to bar. Yes, you can see here. Now these are balanced data set. Okay, now our data set is balanced. Okay, so in most of the cases you have to balance the data set. Now next one is dependent and independent variables. Now our y is spam, this column is the dependent one, and x is balanced, is the x, means based on this we are predicting this, so x and this is y. So we have separate out the dependent and independent variables. Okay, now next thing is here what you have to do, so you have to um, split the data into training and testing. So basically we take 80% of data as the training data set, and 20% data is the testing data set. So from the sklearn library we are using a model selection and importing a train test split method. So xtrain, xtest, ytrain, ytest, we are creating these four variables equal to train test split. We are providing x, y. Test size is nothing but the 0.2 means 20%, random state is 42. So we have to provide any number as a random state, means the training and testing data set will remain static, will not change. Otherwise what will happen if you are not using a random state, so every time when you run this cell, it will create a different data set, and you will get the different output results in terms of accuracy. Okay, so if I run this, and if you check uh, x train shape, I'll check, you can see 1025 is the training data set we have used, and testing how much we are using for the testing. Yes, 257 is used for the testing. This is for training purpose, training, and this is for testing. Okay. Yes. Yeah. Now, here is a very important thing in this particular machine learning model. So our data is completely text data. You can see here, this is this text. You can see here, these messages are nothing but the text. But your machine will not understand the characters or the words or that text data. So basically what you have to do, so you have to convert that text data into a numbers. or number means in terms of vectors basically, so that you have to convert all these text data into a numerical data. Okay, and numerical data means into a vectors. Okay, so for that we have to use a count vectorizer. So this count vectorizer is the tool which is used to convert the text data into numerical data. Okay, so which is a uh, very important and popular tool in the scikit-learn library in the Python is that count vectorizer, which converts the text data into a vectors or the numbers. Okay, so you can see here, convert the each word in the text into a vectors. Okay, so count vectorizer create a matrix in which each unique word is represented by the column of matrix, and each text sample from the document is the row in that particular matrix. Okay, the value of each cell is nothing but the count of word in the particular text sample. Okay, so it will simply just give the frequency of that particular word which is occurring in the different sentences. Okay, so this is all about the count vectorizer. Now we have to import that count vectorizer from the sklearn library, that is the feature extraction dot text import the count vectorizer. Okay, so from here you will get the count vectorizer. Now from the count vectorizer you have to create a object of count vectorizer, and I have created the count vector is the object. Okay, second thing is you have to train the you have to convert your values, this x, because this x you can see here, your x train is x x train is you can see it's a capital X train actually. X train is this. Now you can see here this is the X train. X train is basically a uh, extrain is basically a the text. So you have to convert that text into vectors. Now when you do this, so count vector, this we have created dot fit underscore transform, and we are providing the extend dot values, means these values. Okay, values. So what will happen, you will get a, and we are converting this object to the array. Okay, so you can see here you will get the array of this particular text. So whatever text you can see here, that text. Okay, now our data is now our x data is converted into numerical data, means it's a vector form. Okay, we have converted. Now we can start building the model. So for the model building, what you have to do, so from sklearn dot naive base, you have to import a multinomial naive base. Okay, multinomial naive base, and for this particular model we are creating the object. Okay, so nb underscore model is the object of this particular model. So this is the model. Now we have to train the model. So while training the model means we are fitting the model with xtrain count. Xtrain count means this, and ytrain. So ytrain is already a numerical value. Okay, so when you run this, you will get, now our model is trained on this particular data. Now we will use model for the prediction. So I have used here two emails lines. Is there any Python class tomorrow? Is there any Python class tomorrow? This is one email, and second email is own lottery of $45,000. This thing. So email underscore count underscore vect. Uh, Here I am transforming these emails. okay, because we have to transform these emails to vectors, and then we have to predict the model. Okay, so let's run this, and here you will get 0 and 1. So first one is a non-spam, and second one is the spam one. Okay, so um, this is the customized prediction of the emails. Now next one is uh, we will predict for all the X text data. Okay, these predictions. So X text count is equal to count vector dot transform X test. We will transform this, and Y prediction NB dot model predict X text count. So whatever you will get the Y predictions for the test data. Okay, now you can see here 0101. This is for 257 records, because this is used, we have used as a test data. Okay, test data. Now we have to compare this Y prediction with the Y test, because Y test is the true values, and Y prediction is the predicted by the model. Okay, now next thing is we will compare, and for that we are having a evaluation matrix, like from sklearn dot matrix you can import the classification report, accuracy score, precision score, recall, F1 score. Okay, so when you run this, first we'll check the accuracy of this model. So accuracy score, and you have to give the two argument. One is Y test, means Y true, and Y prediction. So you will get the accuracy of 96%. Okay, so your model is performing well. Let's check precision. So precision is again precision, you have to provide the Y test, means Y true, and Y predicted. So precision is also 95%. So precision, what is precision? So accuracy, precision is, it's a true positive divided by true positive divided by true positive plus false positive. Okay. So it is gives the total number of what, the false positive. If false positive means if the number if the spam the email is non-spam but it is predicting as a spam, that is called as the false positive, and for that we are using a precision. Recall score is we will check, the recall score is again 95%. In this case recall means it's a uh, false negative. False negative means what? um, uh, if the email is spam, but the model is predicting as a non-spam. Okay, non-spam. So that may be the case here in the recall, that is the false negative, and precision is the false positive. So what is the false positive means, here some important messages, emails can be go into a spam folder, and from here from some of the non-spam some spam messages will come into our the inbox folder. Okay, that may be the case. Your phone score is the balance between the recall and precision. So, okay, so this is again the same, because these two values are same. Okay, classification report will give you the complete the report in terms of accuracy, precision, recall, F1 score, and support. Okay, and finally is the confusion matrix. So confusion matrix is the 2 by 2 matrix here, because there are two categories, but it may be a n by n matrix where there is a true positive, false positive, true negative, false negative, such type of the things are there. And based on the confusion matrix, we can calculate the precision, recall, accuracy, and F1 score. Okay, here it is. Now we will visualize this confusion matrix. Okay, So for that, yes, from the sklearn dot matrix, you have to import the confusion matrix, and you have to create the object of confusion matrix. You have to give y test and y prediction, and you will get these numbers. Okay. Now, what this number says means it is 0 0 means it is predicting good, and there are five are the misclassification means uh, what it is telling. So it is saying that yes, this is the true one, but but it is saying that it's a non-spam message. Okay, the same case here. um, it is the uh, actually it's a non-spam, but model is saying it's a spam. So there are two options. It's a true, false positive, and false negative. Okay. So almost 10 records are misclassified. Otherwise this is working fine, right? Yes. So this is all about this model, and here you can test some other emails also, whether it is spam or non-spam, something like that. Okay. So I'll try one more case here. Yes. Your account credited by dollar 89,000. Please call for the same. Okay, so I'm adding one more email here to test it. Yes, so first one is the it's a true email. It is asking for whether there is a Python class or not. Second one is you own the lottery, means spam message. Your account is credited by this number, means again it's a spam one. So 011 means model is predicting good results here. And this is all about the naive Bayes algorithms. Okay. So here you can create also a pipeline of this, the additional one. You can create a classify naive classifier, and you can check again. You can check here the emails, and directly it can predict the values 011. Okay, so this is all about the naive classifier. Uh, it's a machine learning project where we can classify the emails, it's a spam or non-spam. If you have any doubt, you can reach out to me on my email address, or you can call me on this number. Okay. Thanks for watching.